And I have some
From Mount.
it's coming then in my study.
Don't start now.
I think Wi-Fi का problem. उसके लिए किसी नहीं हो रहा connect. Wi-Fi का problem नहीं है, delete होना पड़ेगा. इसके मतलब नहीं हो रहा. नहीं mention my name. That's okay. बिल तैयार कर रहे हैं क्या यार मैं आके पीपीटी तैयार करेगा कहीं यहाँ पर आएगा provide more info.
Focus. This is the problem there.
The broadcast is now starting. All attendees are in listen-only mode.
New one, right? This one.
No, this is stop recording, right?
Yeah.
Now it is started, I guess.
No. Now this.
Click, right? It is started now.
No. This is the stop recording. Started. See, the session is going for below and last. Okay, fine.
Okay. Hi guys, good morning. Good morning all. Lesson today. Okay. So what are the operations we saw yesterday on RDDs? What are the operations we saw yesterday? We did some practice, right? Where we did some hands-on. So on RDD operations. So what are the operations we did yesterday? Val and var. Those are not operations, right? Those is to create a one object. Filter I don't think we did. So we did a map, flat map we did. And also we did lot of yeah, that is we did with the map function, right? Map transformation. And we also did some of reduced by keys also one transformation. Yes. And we also did some actions, right? Count, take, first, collect. Yes, these are all the transformations and actions we did yesterday on RDD. So now let's dig into each and every operations. Let's see what. So we did a map, right? So if I want to, it's just a definition how it just adds the logic whatever you write inside the map to each and every element of the RDD. So the flat map and map we saw the difference, right? So flat map it flattens the entire data set. So it converts arrays of arrays into a single array. So that is what flat map is doing. So now we also did a filter. If like see for example if I have RDD of this, so what it does filter does, it won't take the first element basically. So it won't take the not first element, it won't take the one first. For example, I'll take this RDD. I'll define this RDD 1 2 3. For example, I also have 1 2 comma 1, sorry, 2 comma. I create an RDD here. RDD is created, and then what I'm doing, I am applying a transformation called filter. And also at the same time I'm applying collect. Collect is what? It's an action, right? So transformation, and on top of transformation and I'm applying an action. That's why it is giving me the result. So it removes the one from this. Right? This filter, right? Filter logic. What is the filter? I don't want one from the list. If I want to remove two, I can remove two. That's a basic example. Filter, how the filter is doing. Okay, we also saw filter yesterday, I think. Spark contains, if I want to remove only lines which contain Spark, which contains Scala. Yesterday we also saw the filter. So there is one more action called distinct. Sorry, one more transformation called distinct. I do a distinct, so it removes all duplicates. 1 2 1 3 2 is the one. So 1 is the repeated, 3 is repeated. So it removes the duplicates. So distinct is one more transformation. Okay, okay. You want me to increase the font size? How about now? Fine or fine, right? So that's what I was talking about. Filter, one transformation filter and one transformation distinct. So which will remove the duplicates from a list or array or set. There are a lot of transformations. See, I can also do a union of two RDD. I have two RDD. I can I can do a union operation. I can also do intersect operation. Intersect means one element which is there in first element should not be there in second element. So intersect, I can do intersect. I can do a subtract. Uh, I can do a Cartesian multiplication. For example, 1 into 3, 1 into 4, 1 into 5. 2 into 3, 2 into 4, 2 into 5. 3 into 3, 3, 4, 3, 5. 3, 3, 3, 4, 3, 5. This kind of operation also we can do uh, with the RDD. There are lots of operations. These are the basics example I have taken. Parallelize. What is the purpose of parallelize? I told, right, there are two ways we can create RDD. I told in the first class as well as to second class as well as yesterday also that there are two ways we can create RDD. One is a parallelize, one is the text file. So when you create a parallelize on by using a Spark context object, by using Spark context object only we create RDD, right? So when I create RDD by using Spark context, I can create RDD parallelize that distributes the data into cluster. So 1, 2, 3, 4, 5 is distributed in a cluster. Whatever you see, right? So one will be stored in one machine, another will be stored in one more machine. So that partition will happen based on the block size. But if I want to customize, I can pass as a parameter here. See, for example, if I pass as this parameter 3, so 3 partition will happen for this. It depends on Spark. 1, 2, 3 will be stored in one machine. 3, 2, 1 will be stored in one machine and 1 will be stored in one machine. I can do 3 partition of this RDD. You can see here. There are 3 partitions. There are some operations you can check. You can also check in the UI how many partitions of the RDDs are created. So now what I'm doing, I'm just taking 2 RDDs. I'm just unioning it. Union is one more transformation or action? Transformation. So you can do a collect and you can see the result. What is the result it is displaying? So it is just unioning 2 RDDs. So there are intersect. You can do intersection of RDD. You can do a subtract of RDD. You can do a Cartesian. Let's see this example. So it's just 1 is to 1 into 3, 1 is to 4, 1 into 5, again 2, 3. So it multiplies each element. It just tags each element with the all the one element of one RDD, all the elements of second RDD. Second element of first RDD, all the elements of second RDD. So it's just a Cartesian product. There are lots of operations. You may feel what is the use of this. So when you are building features for a machine learning algorithm, right? Or when you are doing some kind of text mining, or when you are doing some kind of feature building, feature engineering, these are all very important. So in a machine learning algorithm, not only machine learning algorithm, if you are working with any numerical data set in a big data environment, if I want to join 2 data set, if I want to union 2 data set, you can use these operations. If I want to do intersects, it's very difficult in MapReduce world, right? If I want to do union in a MapReduce world, it is very difficult. If you have to think what is the key, what is the value, all these things are very difficult. So when it comes to Spark, right, it is very easy, pretty easy. You can apply lots of operations are there. So those are all the transformations. There are lots of transformation, but I have taken only basics of. I have taken only less transformation among this. So you can apply some actions also. You can apply collect. You can apply count. We already saw that. You can do count by value. Let's take one RDD. We already have RDD, I guess. Yeah, RDD dot collect. So what is RDD? 1, 2, 3, 3. Okay, let's do count by. When I apply action, what happens? we'll get the result, right? Whatever we applied transformation, what are the transformation we applied till now? Map we did, flat map we did, and filter we did, and union, intersect, whatever the transformation we did, all they'll return one more RDD. Now let's see some of the actions. So I have something called as a count by value. So what is doing? So how many threes are there? Count by values. How many threes are there? 2 threes. How many ones are there? 3 ones. How many twos are there? 2 ones. So just doing count by values. So these are operations are very important, and you think of in MapReduce world, if I wanted to do, though it is a small data set, it is just an array. So just imagine if you have a huge numerical data, huge amount of numerical data if you are getting, so you want to do some kind of count by value or group by value, so it is very difficult. You can do it in Hive again, but it takes time, obviously. So you have already seen the take top is the which is the element which is like if 1 2 3 4 5 I have 5 will be displayed. Top 2 means 4 and 5 will be displayed. So reduce is just a, it's like a reduce by key only, it's just some elements. It just gives sum of this. So 1 plus 3, 3 plus 3, 3 plus 3, and then 3 plus 3. So it will 9, 9 plus 1, 10, 12, 13. It is doing summing. It is just adding. So it's again one action. You will get to the result, right? It's one more action. So you can also work with the key value pair. Whatever we saw is just a list, right? Till now we saw whatever we added, we saw that it's just one list. But if I want to work on key value pair kind of thing, key value pair is this kind of 1, 2, 3, 4, 3, 6. This kind of things if you want to do, you can again, there are a lot of operations, there are a lot of transformations action. Reduce by key is one transformation among that. We already saw the reduce by key. If I want to do group by key, I can do group by key. And then, again, group by key is one more transformation. We can see this example again. So it goes groups by key. What are the different keys? It just groups. So for example, 3 has two values, right? 3 comma, you can say compact buffer is like a list, you can say compact buffer. So 4 comma 6. So 1 doesn't have any other value, so it's 1 and 2. If I had one more 1 comma some other list, so it would have given some other. For example, if I had 1 comma 5. So what will be the output? Compact buffer 1 comma 2 1 comma compact buffer 2 comma 5. That kind of thing you can do, and also you can apply some logic on that list or compact buffer. So it's like a list again, Scala terminologies. But if I wanted only values, for example, what are the values I have? 2, 4, 6. I want to add each values, right? Each value I just want to increase the values. So what is this doing? It is supplying logic to values, not to keys. Sorry. This is what my RDD is, right? What is doing that? It is just applying. I'm doing collect at the end. Make sure that you understand this. It's actually map value is a transformation. That then I'm doing collect, right? That's why I'm getting the result. So what is doing? It's just adding each element, each values. It's just increasing the value by 1. So it was 2, now it is 3. It was 4, now it is 5. So only values, not the keys. So there are lots of transformations and action. If you want to get the keys, only keys, you can, rdd dot key collect, you can do, you will get the keys. Only values also you can get. So if you want to sort by key, you can do sort by key. For example, whatever we transformation we did, right, union, collect, whatever, join, before we did for only was two list. Now if you want to join two different RDDs of key value pairs, there are different transformations. For example, subtract by key, so it is based on the keys, it will be subtracted. Whatever we saw with respect to one list, it was, now it is with respect to key value pair. So subtract by key, join, if you want to join based on the keys, you can do joining of operations. You can also do auto join, right auto join, left auto join, full auto join, all the joining operation also you can do. So I hope that you understand left auto join means. So to matching element between two columns plus left tables, not matching between two tables plus left tables unmatched columns will be there. So matching right auto join means matching between two tables, left table and right table, and right. So that's how right outer join, left outer join will work. So we can also apply actions on pay RDD care, count by key, collect as a map. It will remove the duplicates if I have a duplicates map. So you can also do lookup. If I want to get value for a particular key, so you can just do a lookup. For example, if I want to give check the what is the value for 3, right? So it will give 4, 6. That's how it is. That's how it is designed, and these are all the actions and transformation we can work on. This is one intermediate example. So what is this doing? It has, you can assume that this is Amazon has this kind of CSV end of the day. So it's one use case which is there in the production, you can say. That's how they, even Amazon, Flipkart, or any e-commerce website does. So this is the guy, or you can say this is the username, and this is what is the product, and this is how the revenue of that product, so charge of price of that product. Okay, so I want to see what is that product which is sold most for a day. For example, if I have a Flipkart, at the end of the day, Flipkart will see, right, what is that product they sold more, most of the, I mean, one product, unique product, they want to see what is that product they sold more. It can be a phone, it can be a laptop. They want to see what is the revenue, total revenue for today, total revenue for 1 month. The same code will work. They want to see who are the distinct users, so that they can promote some offers and all. They want to see who is that doing a lot of shopping, so that they can give one more offer if he stopped shopping. So these are all kind of analytics you can do with. You assume that this is again a small file. You visualize big environment. So I just want you to understand this code. So what is this code doing? what is this doing? This example is doing the same code. The same code works for a big data and the small data. So I just have that CSV file here. I'm just splitting by comma because it is a CSV file, and I'm taking this. Actually, I used to do with the X, Y. I used to give that name. I'm just taking a proper name. I'm just at the 0th index. I'm putting purchase record, right? At 0th index, what I'm doing, I have this example, purchase record as a variable. I'm just putting 0th index. It's actually a username. This is the product name, and this is the revenue. And I just want to count how many purchases are done. So how many transactions done per day? If Flipkart wants to know how many transactions they did for that day, so if they want to do select star from that in an Oracle database, every second how many transactions will happen for in Flipkart? You can imagine. You can imagine in Amazon how many transactions will happen if they do select star from select count star from the transaction table. So it takes a lot of time. It takes 2 days to execute one query. So its system may crash. So in that case, they go for big data environment. They go for frameworks like Spark and MapReduce. They can run on fly whenever they want. So distinct you can do. Let's count how many unique users. What I'm doing again, I'm just taking one transformation map. I'm taking user, product, and price. So in that I want only users. I have three variables, right? One is the user, one is the product, 3 columns basically. One is the user, one is the product, one is the price. So from that I just want only users. I want to see how many distinct users are there. So distinct, just now we saw distinct, right? Which removes the duplicate. So that's so you can think of, you may think, okay, the distinct, what is it doing? It's the basic stuff. So you just imagine here, what is it? It is doing lot of things, right? Distinct, count also we did. Count is what? It's action. Distinct is, it's a transformation. We did, right? We did. So this is what we did. Then let's sum up the total revenue. So how do I sum up? Price is the one which has the revenue. I'm just converting into a double, which by default will be any type or string type. So I'm just converting price to double. Then I'm just doing a sum. Sum is again one more action. So then now coming to, I want to find the most popular product, which is that most popular product which is sold. So I just take user, product, price. Again, I just assign one to it so that I can count it. It's like a word count. You may think, okay, where is that word count is used? So you can imagine here. So you can see what is that product which is sold most. So you can see product, I'm just assigning one to it. I just do reduce by key. What I do, this is something, whenever I do a word count, right? I'll get the words and counts. I'll get the words and count. But I want the top product which is sold. So I have to sort it, right? I have to sort it in ascending order, descending order. I have to sort it so that the product which is there in the top, which will be the most sold product. So this is something. There is something called sort by key. You have to do sort by second element. So what is the second element? I have a product. It will be like this. I have a product, for example, iPhone, and its count. This is how it works, right? So iPhone, Samsung, 3, and some other product which is 1, and now some other product which is 10, some other product which is 5. So this is how word count looks, right? Like word count, at the end I will get this kind of thing. But I want the top most sold product. So how do I do that? I need to sort based on these values, right? Sort based on this value. That is what it is doing. Sort by second element. Second is what? Values. But I want in a descending order. So in Scala there are a lot of shortcuts. So you may not understand as of now. This is hyphen. You can see, right? Hyphen here. If I do hyphen, right? So it will sort in a reverse order. It's very beautiful. Scala is actually, if you see all these things, right, it's very beautiful. But again, once you start writing the code and all, you will understand. So again, in that, so this is what the product, most popular product, which will be there in the index 1, right? So it will be there in the index 1. Once I sorted, right? Once I sorted, this is the most popular product. This is the most popular product. At index 1, I'll have the product. Sorry, at index 0, I'll have the product. So I'll just do index 0. I'll get the most popular product. So this unique user, I'm just printing it, total revenue and most popular product. That's how it is. So this is one example. It's a one kind of real-time example you can think of. And then if anybody wants to know anybody wants to do this kind of analysis, that data engineer will do. If somebody asks, oh, not in this class, in the previous class. Okay. So what is the difference between data engineer, data scientist? So this kind of job data engineer will do. Data scientist will apply machine learning algorithm. This kind of job. So I want to see this. So basically ETL kind of thing, and some kind of mining, some kind of. Mhm. This one you are talking about? This is the lambda function. Inside the lambda function, this is all syntax it is. This is lambda function syntax of Scala. So lambda function is a function without name. I can define any logic. What is the logic here? I am taking three users. I have 3 columns. So in that I just want only 1 column out of 3 columns. So which is the user. Instead of this, I can have a x0, x1, I'm sorry, I can have only x here. I can specify x of 0. So which is actually index of 0th element. You can do the same thing which we did here. For a naming convention, we use case. So better naming convention, instead of x, y, z, instead of putting that, let's have a proper username and proper product. That's how it is. So if you want to read the data from HDFS, I also show how do you read the data from HDFS, though I don't have Hadoop installed here. So you just have to specify the path localhost. If it is Hadoop 2, right, you have to specify localhost 9000, and the input, if you have done any any operations on Hadoop, you can see that its input is a directory, and this is let's say I want to read a text file. So then I just have to specify HDFS path here, HDFS : localhost. This is how you just have to specify sc.text file. It will create a RDD. If it is stored in 3 blocks, 3 partitions of the RDD. That's what it is. These are all the assignments which I give. Okay, how many of you remember word count example? What is the word count was doing? Let's go back to one word count example so that I can visualize and show you. Yesterday it was not there, right? Recording was not there. I'll show again this same slide. I was just talking about this. So for 10 minutes we'll go through it again. Recording is not there. You can go back again, see the recording. So driver program, what is the driver program contains? It's a main function, right? Main function which will have where we can write your RDDs, transformation actions. So what is the Spark configuration object contains? Application. What are the, for example, what are the parameters you want to execute? What are the parameters you want to execute your job? How much memory you want? You can specify in the configuration. You can also pass as a XML file, but also you can specify in a program itself. For example, I want a worker node of 4 GB. I want that worker with the 4 GB, executor of 2 GB. If you are specifying that kind of thing, you can specify here. And Spark context object is to access the cluster. Once I have accessed the cluster, with the help of Spark context object, I create a RDD that we already saw, sc.parallelize. So how do you transformation? There are a lot of transformations and actions we can apply. These are the operations on RDD. So if I apply transformation, I'll get another RDD. If I apply an action, I'll get value. So we also saw this word count example, right? This we also saw this example. We also saw some filtering if I don't want to see the line containing spark, it will remove the spark lines. We also saw some of the actions and transformations. So this is the word count example. Let's copy this example. I I think I have this file. This is the file which I have. We also did a lot of transformations, right? Filter. We removed some of the lines if I wanted to remove as part of RDD. So what I'm doing, I'll just load this file. So and also I told RDDs are lazily evaluated. So when I read the file, text file, do you really think that it has read the file into a RAM? No, why? It's a transformation. It just created an RDD. So I can apply a lot of transformations on top of this. Now, so when the job starts executing, when action is applied, right? So let us see. So let us see. This file is not there, right? This file is there or not there? If I want to just Spark note, is there that file? Is there something like Spark note inside my machine? No, right? Let us see. No, I don't have that kind of file, right? Oh, sorry. I don't have that kind of file, right? So I have Spark nodes, some other Scala and some work, test app, Spark app, all these things I have. But I don't have this file. Which file? I don't have this file. Okay. So I did one transformation. I just created one RDD. So now let's take I did one more transformation. I just did a flat map. So do you think that it has done a transformation, real transformation that has split the lines into spaces? No, right? No, right? It should have given an error if it was there. Now let's call an action called collect. If I call an action, then it job start executing. That is called, it is called RDD is lazily evaluated. So it internally prepares a logical plan. So what it has to do? So that is called lineage graph. I already told why it is called resilient. Why it is resilient? Because of this lineage graph internally. It stores a lineage graph. When I call an action, it start executing. So then it will tell the file, it will throw an error. The file is not there. You can see that error, right? Lineage graph. Lineage graph. I already told, right? Lineage graph, why it is partition and all. So you can see that what is the error. Input part does not exist because that file is not there. So when you call an action, then only you will get yeah. So let's take, that's why it is called as an lazily evaluation. You can see this is the now flat map I did instead of map. If I would have done map, I already told yesterday. So let's say if I want to apply a map here, the logic is the whatever the logic I have, it will be applied to each and every line. So it creates arrays of arrays, one array for each line, right? Though it is a collect returns me in the form of objects, array object. So it won't flatten the entire data set. It just it applies the logic to each and every line instead of applying to entire document. Individually, it applies each and every line. So if I do a flatten of the document, so it creates only one array. It returns collect returns, though collect returns only in the form of array or list. So this is how the flat map is doing. I'm just again what I'm doing. I'm just assigning. You can see what is that is doing. If I want to see what words with the numbers, you can see what is doing. It is just assigning Spark 1, Apache 1, Apache 1, Spark 1 is 1. And then at the end, I'm doing a reduce by count, reduce by key. So it's also one transformation. I do a collect. This is what we discussed, right? So you remember the architecture. I explained the architecture of Spark. What all things will be there in Spark in the architecture diagram? That's one wrapper. In the architecture, Spark driver, yes. Cluster manager, yes. Name node, yes, it can be the name node also. Worker node and executors and then task. So what I'm doing here now, it's a standalone. So everything is on one machine, only one worker node and only one cluster manager inside the same machine. It's called pseudo distributed mode, right? Everything is in one machine. Cluster manager is standalone. So in production, this is not happens. Production worker node will be at some place, driver manager it will be at some other place, and then cluster manager will be at some other place. The idea is why I ask, because I'll explain you guys this advanced architecture is actually. So this is how the Spark we saw, right? Spark SQL streaming, MLlib, everything is converted into Spark core. Now I have this is how the example looks like. So we have all your application code we submit to a master, and then we have a worker nodes. That's how it looks like. We also saw this example. This example also we have a cluster manager. This is a basic diagram you see everywhere. Driver program is one, and we have a Spark context. We have a cluster manager. We have worker node, executors, and tasks. So executors are JVMs. Worker node is the one on top of one machine. Each worker node will be there. You can see one more example. So now I just want you to understand how this is happening. I just need somebody to explain me this example. What is this example is doing? Where is the data movement is happening? I want that. There is somebody should tell me exactly at one point I wanted that point where exactly that point is data movement is happening. I already told. What is doing? Just okay. Let's be with me. What is this doing? I'm just taking the file input file word count file, loading the file. I'm just taking that file. I have created an RDD. Input is an RDD. So now, if that RDD, the data set is in 4 block. So how many partitions will be there? 4 partitions. So 4 partitions will be there. Okay, fine. Now this logic is applied to each and every partition. What is that logic? I'm just taking each partition. I am just applying each line of each partition. I'm just splitting. So this will be applied parallelly on all the worker nodes. Now what is doing? Word count, words, then word. Okay, this is till here everything is same. Till here everything is same. It's here, right? Word, one word. Word and one. Word comma one. Word comma one. Word till here. Now this is where the reduce by key. This is one more transformation. What it does, it collects all the keys at one place. At the end of mapper, right? In MapReduce world. At the end of mapper, what it does shuffling, right? So that it can collect all the keys at one place by using hashing mechanism. That is called by internally it uses hash partitioner. By default partitioner, it uses hash code and equals method of Java or JVM. So that what it does, for each object it generates unique number by using hash code, and it checks the equality by using equals method. So what it does, it collects all the AA will come into place into one bucket, all the B's one bucket, all the C's one bucket. So if I have a 3 reducers, so 3 partitions. So A to Z will be divided into 3 partition. So you can say A to F will be one partition, F to some other, and then from other to O to Z will be in some other partition. So 3 partitions. So the same way what is doing, reduce by key is aggregating all DD into one place. You can see here. Time into one place. IND into one place. Okay, IND is there in one partition, IND is also there in one more partition. So whatever logic you applied, that was applied to that partition. So till here. Now, but I want to collect all. IND is there in Spark 1 is there in one partition. Spark 1 is there in one more partition. Spark 1 there in one more partition. And then how many sparks are there? 3, right? It has to come into one place, right? So that's what it is doing, reduce by. So data movement is happening at one place. At this time, reduce by key. So now if I do a save as text file, then all jobs start executing. Save as text file is one action. Then it checks for the parent RID. Who is the parent RID for this? Okay, counts. Now it checks for the whose parent RID, words. Now words. Who is the parent RID for what? Input. Okay, then it starts reading. It applies the logic. It applies the map. It just splits at each partition level. It just assigns one word, and then it just reduce by key, and then all the keys will be collected at one place. This is one example. So internally, yeah, this is what I was telling. See, if I have 4 partition added. Why 4 partition? 4 blocks. Yes, 4 blocks. So internally it prepares this kind of logic. So internally when I do a text file, right? SC.text file we did, right? To read the data. Internally it creates Hadoop RDD, map partition RDD. So it created a 4 partition at 4 different worker nodes. So it is working parallelly. So I applied a flat map. The flat map, what is that flat map is doing? It flattens, right? That flat map logic is applied to each partition parallelly. And the map, again I assign one word to each. The map logic is applied to each and every partition of the word. That then what I do a reduce by key. When I do a reduce by key, then it starts shuffling. So all the C's will come into this place, all the B's will come into this place, and all the Z or whatever it is come into this place. This is called as a lineage graph internally. For example, let's say this entire machine is failed. Okay, during this process, okay, you assume that this is failed. This operation is failed. Flat map operation is failed. So what it has to do, Spark? It has to find the parent RD. It just goes here. And it just goes here. Then it can read data only for that block. This is called lineage graph. It's a fault tolerant. Feeling bored? Lot of setting. Okay. See, please understand this. So why it is called lineage graph? It is very important. Why it is called fault tolerant? See, if this entire machine is failed or this part is failed, so Spark is smart enough to rebuild entire structure by using this kind of architecture. If let's say this is failed, this work is failed, or this job is failed, so he can go back to his parent ID and he can build this again. This is why it is called. It's called lineage graph. So what happens here? When you apply this is called logical plan. So here, where is the data moment happening? Sorry. Where is the data moment is happening here? Tell me. All the Spark is collected to one bucket. Where is that happening? That is actually data moment, right? Spark is there in 3 machines. Spark 1 is there in 3 machines or 4 machines. So then I want Spark 4. Spark 1 is there in 1 machine. Spark 1 is there in 1 machine. Spark 1 is there in 1 more machine. 4 partitions, right? At the end, I want at 1 machine, so that I can apply logic. Spark 4 I can do. So Spark 1 is there in 1 machine, 1 machine, 1 machine. So I have to bring back to 1 machine, right? So that I can do aggregation. So that is called data moment. I have Spark 1 in second machine. I'll put into one machine, first machine. I'll copy and paste. So this is called shuffling. Data movement is happening. So where is the data movement is happening? Reduced by key, right? So there is, until unless there is no data movement, right? All the operations are done parallelly. Once the data movement is there, right? So it has to aggregate. So this is called stage 1. Until unless there is no data movement, all the transformation action you applied, right? What are the transformation you applied? You applied a flat map, you applied a map. So all they are combined together into one stage. Once, okay, till shuffling, after shuffling, again one more stage. If there is no shuffling, everything will be completed into one stage. You got it? One more time. So reduce by key, I am using it is a word count example. I am using reduce by key because I want it. At some point of time, I don't even want reduce by key. For example, I want distinct count. At that time, I don't want reduce by key, right? There is no data moment. But at the end, driver will collect the result. Driver is the person who collects the result from all the workers. But here, what is happening? It is happening. The data moment is happening. So what happens? Now I have to collect until unless there is no data moment, right? I'll combine all these things to one stage. All these things into one stage. The what is stage you will come to know in further next slide. So next transformation action is given as a one stage. So now any doubt here? Please. So can anybody tell me? One person. Who will tell? Can anybody tell me? You will tell? What is happening here? Tell please. Even if you're wrong, it's fine. Yeah. So why it is four blocks are there? It is partition. It is called RDD. Yes. So parallelly, it has done a something called Hadoop RDD, and then partitioned. It has partitioned to 4 parts. Now, what is flat map is doing? Flattens the entire data set. Now, it's just basically I'm just splitting it and flattens. So that logic is applied to each and every partition. The same logic. The next is what? Map, right? So I'm just assigning word and comma 1, word comma 1, word comma 1. That will be applied to only that part, that block. Then what is reduced by key? It will aggregate all the keys. First of all, it will aggregate all the keys at one place and it sums. Right? The data shuffling is happening. If I have a Spark in another machine, I'll bring it to one machine so that I can do aggregation. So this is all shuffling is working. So yes, that's yes. So it has a graph, right? Fault tolerance, yes. That is also called as a resilient. I told in the beginning in the first class. And also it's a lazy evaluation, right? It has to know, it has to prepare a graph and then it can execute, and it can take a shortest path among that again. Name node is gone, then everything is gone. So name node, let's say this block is whatever is there, this block is there, right? This is coming from one machine. If this entire machine goes down, so Spark is smart enough to contact name node to check where is the replica of that, so that it can rebuild only this, not entire stuff, only this stuff. So this is all. So why it is stage 1? I mean, until what point it will be called a stage 1? When there is no data moment, that is called shuffling. So that will be combined into one stage. So you can see here that whenever I apply an action, that will be combined and given as a logical plan, right? Logical plan was there before this. It was a logical plan, right? So when I apply an action, like for example, save as text file, that will be converted to a physical plan. So this is one partition. What is happening is I combine all these things to one stage. You can see here one stage. This entire stuff I combine. I'll combine as one stage. See here, all 4 operations I did, right? 2 operations I did. Flat map I did. A map I did. So all these are combined into one block. One block, one block, one block. Okay, that will be given to task scheduler. So each task, here you have task, right? You remember executors and task I told. So each task will take this part, entire stuff will taken care by each task. Parallelly, one task will take this, one task will take this, one task will take this, one task will take this. So one stage, so that it can run parallelly. So 4 tasks are there. If you have 4 tasks, 4 core machine, 4 tasks work parallelly on this partition, this partition, this partition, this partition. And this is one more stage, one task, one task, one task. That's how internally it is working. See here, it's very important. One more time. See what I'm doing, I'm just aggregating all these things. Since there is no data moment, I combine all these things. I can run independently, right? This logic independently I can run. So it is not dependent on this. It is not dependent on this. So I can run independently. I can merge all these operation or transformations into one task, and I can merge all this transformation into one task, so that I can give one entire task to one guy. That is called executor task thread. I can give that task to the task thread. What is the task? It's a flat map and map. Parallelly, 4 thread can work on this data set. Once the task 1 is finished or stage 1 is finished, then only stage 2 start. This is the job of again scheduler. This all comes under standalone cluster manager. That's how it is working. So you can see what is DAG, director acyclic graph, right? So what is the DAG is converts all this logical plan into physical plan, and all this stage will be combined. So it will not come here, and also it will shut down if you put the charger. You wait for 2 minutes here. You can see the screen how it is happening. You wait for 2 minutes. What will happen? See what I was talking. ठीक है, ठीक है, लगा दो, 2 मिनट लगा दो. So what? See, if you see the physical plan, right? DAG, directed acyclic graph, is the person who converts all the logical plan into physical plan. When you apply an action, all these things happen only when you apply an action. So all the tasks will be combined into all the stages, right? Stages, there are 4 partitions. So all those things will combine into one task. Like you can see the logical plan, right? That will be given to one task thread. So that will execute parallelly. So you can see here, this is the HDFS file. Down you can see HDFS node, data node is there. So then task scheduler is the person who schedules the task based on there are a lot of mechanism, again FIFO, again first in first out, that is actually FIFO, phase scheduler. You can configure in a XML files. So DAG is directed acyclic graph. So we have a different nodes and edges. These are all the nodes. One partition is called node, and internally it has a graph, right? All these things, graph edges connecting between this node and this node. So why it is called DAG? Because it's acyclic. You cannot go back to old partition. That's why it is. You can go back again, but you cannot have a cycle, right? What is the use of DAG? Why it is called DAG? What exactly? It internally has a it is called lineage graph, right? So internally it can rebuild the entire structure if something goes down, if that partition is failed, by using this kind of graph. So it will have a proper plan or proper diagram. It will have in mind that what it is failed. That's why they have given that name. It's also called a lineage graph. So all this physical plan, right? Logical plan is there, right? So that will be converted into a physical plan by combining all the stages and all. That is also inside this, there is something called DAG scheduler also. So which merges all this tasks, all this partition entities into one stage. So basically what is doing, so if one partition is failed, by using this kind of graph you can rebuild. So you are moving from one transition to another transition, right? You are moving from one state to another state. Here you can move, you are moving from one state to another state. You are moving from one state to another state. Right? That's all it is. You have any other doubts? So let's see one example. So what I was talking. So in this example, so how many stages are there? How many stages are there? Two stages are there. Why two stages? Please tell me. Yeah, one is the data moment, right? Okay, data moment. Okay, now let us see this whether two, if I execute word count my execute, how many are there? I'll execute this. Oh, you can see what all the jobs I did. See here, how many stages are there for this word count program? Just now I executed, right? Two stages are there. How many stages are there? How many tasks are there? Each at each position it is created one task. So how many stages are there? You can see all these things, and also you can see DAG. So which is completed stages 2, right? What is that? Okay, let me show you. Okay, this is what two stages are there, right? Why two stages? I told, right, two stages are there. It will combine. There is until there is no moment of the data, it will given as one stage, and rest is the another stage. So two stages successfully executed. You can see all the stuff. So DAG looks good, but I don't know, somehow it is not coming. So inside one stage again one task, you can have a 4 task, but it's not a, if you have a 4 core processor at a parallel it will work on 4. Yeah, tell me what is your doubt? Event time. So when you submitted, where is the event time? This event time, okay. All the, what is the executor added, stages completed, failed. You want to see this admin job. You how many executors added? Executors are what? JVMs. How many stages completed, failed, archived? You can archive again. So DAG looks good actually, but somehow it is not. You can see how many. It's actually till here one stage, till here one more stage. No. Manually, how can it's on fly, right? It is running actually. So you have to configure everything before you start the job. Before the starting the job, it's a processing. So you before starting the job, you have to add it everything. So you can configure all these things, executors, worker nodes, as you can create a cluster. Based on your system RAM availability, you can have number of executors. Each one will take 512 MB RAM. So you can configure if you want less RAM or more RAM if you have a good infrastructure. Right? This is what I want to tell. Two stages are there. Oh, I'll tell you later. Okay, any other doubts? No, right? That's it. Thank you. Okay, what is the what he's doubting? What is the cluster configuration? And all? It depends on your data set. So if you are working recommended what is your data set? Recommended ones if you are working on Flipkart, obviously it will be 100 node cluster with like 30 GB RAM of machine with some around 1000 or 1500 GB hard disk with some cores of processor. So for maybe 10 core or 15 core, half a core, depends on your data set. If you are working company like Flipkart, again they have thousands of rules. And we support the structured data. We also showed the example. I showed an example. Right? It is structured data, right? Semi-structured data actually. Not semi-structured, structured data itself. CSV file. I showed right CSV file. How it's loading, storing in any database? We have not created any database. It's a local. Everything local. I have showed the in production what happens, the data will be there in Hyderabad or data will be there in Cassandra. They are most of the database. It can be your relation database, but you can read from relation database. Any other doubts? I hope that you got something at least. Okay. Thank you very much for your time. Any other doubts? All right.